why don't we welcome Mark Papermaster in. Mark, it's superb to have you here. First, welcome, and why don't you just briefly introduce yourself and we'll jump right in.
Great. Well, Drew, first of all, thanks for having me. I really love talking about technology. It's been my lifeblood. I've been in the industry over 35 years, and IBM working on their whole range of technology. Apple with running iPhone and iPod development for Steve Jobs. Cisco, and then the last almost 9 years at AMD as Chief Technology Officer and running our R&D engine.
That's fantastic. What a great story. And I'm a Silicon Valley native myself, and remember some of the colorful battles between Jerry Sanders and the old AMD and Intel and all those good times. So this is going to be fun. Why don't you just share with us briefly your kind of role? We know your title. I believe you're heading up engineering and innovation in addition to being the CTO. So you're a busy man. Again, thank you for joining us. But tell us about your remit. What's a day in the life of Mark Papermaster?
Well, I've got a great job because, again, I love technology, and my job's twofold. So as a CTO, Chief Technology Officer, I really have to be staying on top of where the industry's going, really listening to customers, understanding the trends, and making sure that that our strategy addresses those needs. So it's about the strategy, the roadmap, really helping bring us together internally in the company to have the right focus on technology. So that's one, and then I also have a dual job of running a piece of our engineering, which delivers our microprocessors and our core technology across the company. So it's a great combination that allows me to do what I love best and work with engineers and help get great products out and work with customers. And I've got a knack for listening. So like I said, it's a lot of fun.
Yeah, I think the most successful people are those who are curious and listen. So before we jump into the real meat of the discussion, obviously these are uniquely challenging times, and talk to us about how you've managed, and if there's even sort of been a company ethos, and how you've managed your teams remotely. And AMD is interesting, where a company like, certain software companies may not have to have anybody in any kind of office or facility, but there are people there that still have to, in the fabs, that have to make the product. But in terms of, sort of your role in the company broadly, how have you managed sort of the last 6 months in managing remote work teams, keeping things on time, keeping innovating, and what's your advice for people out there?
That's a great question. I mean, it is such a challenging time across the world. For us at AMD, we were fortunate in that we are a global company. So our teams are spread out across North America, India, and across Asia, Europe. And so we had actually already developed, part of our culture was to communicate across the sites, really use the medium we're on today, audio-visual conferencing. So that was already built in. But it very much was in the office and in the lab environment. I mean, we're a tech company. And so we are fabless. We don't have the semiconductor manufacturing line, but we have many engineers that are in the lab, testing our products and getting them ready for market. So we've kept that going on a central basis. Of course, our facilities team did a great job ensuring we had all the right distancing and safety measures in place. But for the rest of the company, across many of our geographies, it was almost an abrupt shift to work from home. And so what we found is, yes, we were used to video conferencing, but not from home. Right. So it was our IT team did a great job and beefed up the ability to handle the load on the system. We had fortuitously made some investments to make sure we had the right network bandwidth and processing capability. So we were pretty good there. And when the team reacted, so the biggest thing, Drew, was just getting the mindset of the team of, just all of us learning. And frankly, that the team was so resilient. We really didn't lose a beat in terms of our R&D and research and development, of course, and developing our products. Really proud of the team, but it is hard, and it's a different environment. It's a bit exhausting, actually, when you find yourself, in this kind of mode, just sort of on camera, because
Right.
suddenly we're all on camera all day.
Yeah. No, we all know the feeling.
You
And
asked
I'm going to go.
my suggestion. So the one
Yeah.
suggestion is over communicate. I mean, just
Mm,
you used to rely on running into someone in a hallway and things like that. So my suggestion is,
right.
and what we've tried to do is just always be proactive. Just reach out, give someone a call, a video call like this. I think that's essential. Over communicate.
That's great. And I want to go one layer deeper on this question. And I did see a question just come in that's sort of related to what I was going to ask. The question that someone just had out there was, what tools are your engineers using as sort of their remote? But my related, I was going to ask you more along the product innovation side of things, to keep, you guys have to continue to innovate. You're in a hyper competitive market. You're always innovating, and product innovation is central to the company. Have
Yes.
you done anything different in regards to product innovation, whether it's using software tools or programs in terms of, or are you kind of using the same, types of tools and programs that you did to track product innovation and hit your milestones? And, or is there something different you've added to the mix since we've kind of gone remote? And that could be related also to tools that your engineers may be using specifically as they've gone remote. You can answer either or both.
Sure. I'll mix. I'll try and mix an answer to both as I go through this. So, first of all, we have a culture of metrics. I mean, innovation doesn't just happen. New products don't just pop out. It turns out you have to manage them pretty maniacally. And so we have, very much a metric and milestone-driven innovation development process. And it does start in that ideation stage, that innovation stage of what's the problem? What problem are we trying to solve? How could we solve it? And let's pick the three best and kind of run down the road a little bit with each of them, and then pick one and take that to market. So that whole ideation stage, it's not as effective. I mean, it's great. What we used to do is fly everyone to one spot
Right.
and run that as sort of like this brainstorm. And look, when we're past this crisis, we'll go back to that, because there is no substitute for that bonding and that in-person teaming, and just seeing that motion even more more detailed from the person you're chatting with, or the people you're chatting with. But we did take it to the format like you and I are on today. So small groups, we would run that, and it's really proven pretty effective. I mean, including like a digital whiteboard. All of our tools are in the cloud now. And so if you're creating a presentation, it's on the cloud. I could be typing something right now on my ideas. You would see every letter as I type it. I can draw as a drawing. You're going to see it. You see it done. And even in our lab, we did remote instrumentation on our tools. So a small group would go in the lab, but with the remote instrumentation, you can log in. It's called telnetting into the Linux box there, and still be able to control and run experiments in the lab, although you're sitting at your setup at home. So it is in fact the interactions of old, but new in different ways.
That's great. Thank you for that. And finally, before we leave this subject, sort of when you're talking about this innovation development, are you using specific software programs, or did you create sort of your own innovation sort of development tracking software, the milestones, managing these projects, or do you use something off the shelf?
We generally, we have a combination of off the shelf and in-house. We try and use off the shelf, because you don't want your own where you want your programmers, it should be where someone else didn't invent it. If someone else invented it and meets your needs, you might as well use that. It's a better use of your resource. So what we do, all of our online communication tools and that's of course off the shelf, from all the usual suspects of vendors out there, and we have a strong partnership. So that's and our employees are operating home from laptops, and so they're using laptops from Dell and Lenovo and HP and or Macs, and we supply to all of those. So they're using our own products and how they're operating at home, and then from a collaboration standpoint. And tracking, we find out that the details of how we manage the milestones, as you say, that we do in-house. So that typically is more advanced spreadsheet tracking, and we do have some additional just project management tools that we use. So yeah, it's really a combination of both.
That's great. Let's jump to the market and your sort of specific market and industry at a macro level, and then talk a little bit about where AMD fits into that. Give us sort of your overview and how you see the broader, I'll call it, chip marketplace or chip industry, even though that's probably not the right terminology necessarily to use. But how do you see your industry now and the landscape, the competitive landscape, and where AMD is fitting in that now, and then maybe a little bit about where AMD is going? Obviously, you've moved to some high performance products and things like that, but give us the lay of the land of your
Yeah.
industry.
Well, it's very interesting. Again, as I said, I started in this industry over 35 years ago, and believe it or not, the engines, the chips, are more important now than they ever were. And I never would have imagined that they would have only grown in importance over that period of time. But the reason is, and you alluded to it, is the demand for higher and higher performance. What's happened is programmers have really moved the state of the art of algorithms of what it can do. So, the world is in this transition right now where there's these IoT devices implanted all around us. We have smart homes,
Yep.
smart offices, smart factory floor. And so we're getting all of this data. And how do you make that data useful? You need to process it. You have to compute, and you have to make it useful. And then the algorithms, in fact, have to be smarter. They need to be really taking many factors into account. Well, this is Drew, and Drew is in the communications industry, and what data might he want, and how do I make it useful for Drew?
Right.
And so there's a lot more processing that's needed to make all this data useful. And around 2012, a set of researchers took an algorithm called the gradient descent algorithm that had been used for years, trying to push optimizations forward, and applied it to in a approach of machine learning that allowed a much higher accuracy of object recognition and voice recognition and processing of data. And so that is also spurring a rapid demand for high performance computing. The Microsoft Turing model, it's just got, it's just shown it has these massive models sizes can get incredible accuracy.
Right.
And so all of this is driving a demand for higher and more performance. We need it in our own home. We're gaming at home. We want more visual acuity. We want it to be more lifelike. It used to be 1 per C per household, but with work from home, we're seeing 2 or 3 PCs per household. So all of these things have just hit such an inflection point where we need more processing for analyzing the data, make it useful, make it smart and intelligent, and visually appealing to us, whether it be for entertainment like gaming or just visualizing the data for my work.
And what has, more broadly, again, sort of the macro view, what has the rise of mobile, right, and just smartphones and all the, I've got 10 applications running at the same time in the era of sort of open APIs and things like that. I mean, has that really driven this sort of, need for performance but talk to me about sort of the impact of this new, just, sort of mobile world on how you guys see, the competitive landscape, and then where you need to go to continue to compete.
Well, what does a mobile world mean? It means that all of us need to be able to get at what we need wherever we are. That's what a mobile world is. So we are connected with a smartphone and typically a PC or a tablet device everywhere we go. And what that does is it means that to get it, think about it, you used to have to take go back forever. It was, stacks of floppy disks. Then you didn't even have mobile computing, but
Right.
then it was your flash drives, a little USB drive, or you'd need that data, or you'd store it on your PC or on your phone. Well, you don't think that way anymore. Why? Because we're all accessing the cloud wherever we go. And so mobile computing has changed to where you can work anywhere. You take your mobile device with you, but you can access a vast array of computing from the cloud wherever you go. That had immense impact for our strategy at AMD. So if you go back, 7, 8, 9 years ago, almost all of our business was PCs.
Right.
And we set the strategy to, driving AMD to turn around its fortunes and to drive to be, the leader in high performance, because we saw this trend coming. We saw artificial intelligence, we saw the move to the cloud. And so now we do serve the most demanding server processors to the cloud. We're in all the major cloud vendors that are out there worldwide. We are in the edge of the computers, what's called the edge of the cloud. So you think about, when you get information on your phone, it started in the cloud, but then it went to a cell tower and it had processing underneath. And it's 4G today, but it's rapidly moving to a 5G, very fat pipeline to get you information wherever you are mobily. And so what we drove high performance all the way from supercomputers that we've just recently won a bid for the most powerful supercomputers from the U.S. Department of Energy, to the cloud, to the edge, to the PC and the mobile device that's going with you everywhere. So it's this trend has we've reacted to it fundamentally in the strategy we set out at AMD to be a leading provider of highest performance CPU, which is the general processor, and GPU, which is used in gaming and graphics compute.
Right, and I want to dig into this innovation story in terms of moving to high performance, but I do, I promoted this session a lot talking about sort of, is Moore's law dead?
Okay.
But tell me, for the audience, and maybe just for those who aren't aware, can you just give the 10-second overview of what Moore's law is? And then what is the state of Moore's law? I mean, and is it still relevant? And you had talked about innovating our way through or past Moore's law, but let everybody know what it is briefly, and then how you see the state of Moore's law.
Yeah, Moore's law was, a paradigm that was set out really at the beginning of the semiconductor industry as we know it by Gordon Moore. And it said that the transistor density of what you could put on a chip would double about every 18 to 24 months. And we've largely held to that doubling. So in the traditional definition of Moore's law, it's actually still running strong, still true, still running strong. But Drew, it's not the same, because the way it was for many years is you were on that Moore's law doubling of transistors, but the cost of the transistor itself would stay the same, or actually go down significantly, generation to generation, and the frequency, how fast you were running those transistors, would go up generation after generation. That's what's not the same, and so we're just not getting the speed bumps we used to. So you are able to pack more transistors in, but the cost of those transistors is going up, and we're not getting that frequency speed boost we used to. So it drives a whole different kind of innovation. As the suppliers of these engines to the industry, we have no choice. We have to stay on that old traditional pace that we've been on for years of getting end users more performance at the pace they had been used to. So yeah, it drives a whole different ways to think about what Moore's law is today.
That's fascinating. Well, let's talk about this sort of innovation story. Like I said, we've been looking at a lot of innovation stories, even open innovation. There's a lot of innovation theater out there, but the AMD move to high performance is not only just a real core innovation story. It's innovation that transformed a company, right? It transformed a company. So I mean, it can't get any more real, and impacting the entire company and its future. So, when that decision was made to move to high performance, and seems pretty obvious why that decision was made, just in terms of where the market and where consumers were going, what was the first thing you did? Or did the company do, or the C-suite, is say, okay, how did you start that process when you really need the whole company to really buy into a real fundamental sort of innovation or transformation? And walk us through the early stage of that decision and how you started that ball rolling.
Well, luckily, Lisa Su, the CEO of AMD, and myself go way back. We worked together early in the industry, so we had a very, very close partnership, and we had to make a lot of tough calls. So, in any transformation, it's tougher and tougher before it gets better and better. We actually had to cut research and development budgets. And so you can say, well, my goodness, that's a terrible environment. to drive high performance and to drive this kind of innovation. But exactly the converse is true. We faced a crisis. Everyone in the company, we knew that we were in a crisis. If we just continued to do what we had been doing, it was not a good future. And so there was a sense of urgency, and what we aligned on is to protect the spend and grow the spend around the base engines, the CPU and the GPU, and plot out a future of how we could intercept where the market was going, high performance, which is exactly what happened starting in 2017 with the launch of our new family of CPUs, the Zen processor. Yeah. And we've just like clockwork been coming out with new generations. We have our third generation of that Zen processor shipping into this year, and each one brings a significant jump in performance and performance efficiency.
In regards to those early days, it's a great product innovation story. And right now we're all companies are going through this sort of acceleration of digital transformation, largely maybe driven by COVID, but digital transformation was happening and now it's accelerating. You guys faced a similar situation back then where survival, being able to compete. So you had to accelerate, I would think, sort of, how did you manage that process, both sort of the early R&D phase, moving to high performance, and then as you really started to develop the product? There's anything different you did in terms of managing that innovation process where sort of speed was really critical? Like you really had to get moving.
Well, speed for sure is critical, but first and foremost, Drew, is actually culture. We had to have and we were very open about this as a team in AMD. So as we were going through this turnaround, we really set a culture out that was in R&D grounded on really four principles. One is transparency. I mean, again, we were the smaller company versus our competitors. We don't have time for any politics or right. Any of that. It's just everyone's got to be really completely candid and open on what's working well and what's not working well. You got to call the ball on what's not working well. And then that moves you into problem solving. You got to call, if you have good transparency, you call out where the problems are and you glom around it. And then third is decision making, being crisp and moving fast at decision making. And then lastly, taking risks. But taking risks in a way, we talked earlier about innovation, managing innovation. Right. You got to have the metrics around risk. Are you managing the risk? And if it looks like one of your bets isn't going to make it, did you take corrective action? So everyone thinks it's magical and innovation is and culture change. It just happens. It's actually a very managed process and one that requires very, very high communication across all levels of technical leadership in the R&D teams and management.
And related to that, a question just popped across, and I'm going to relate it to a question I was about to ask anyway. My question was going to be around, did you change? There's a lot of discussion now about matching, and there always has been, it seems like more now, around matching your talent strategy to your business strategy. The question was, did you have to cull any employees? And so, did you have to let people go? But my question related to that was, did you also then look for different types of people, like different types of engineers? Did you change sort of your talent strategy or talent acquisition strategy? Did it require a different type of person who maybe has sort of that innovative sort of spirit in their DNA, that curiosity? Or how did you match the talent strategy or business strategy to achieve that and drive that innovation? And maybe including, did you kind of have to let maybe some people go that just either weren't on board or didn't get it or whatever?
Yeah, we did all of that. So obviously, if you go back and look at AMD and 8-9 years ago, it was a tough time. We were charting the turnaround. We weren't coming up the other side. We were in that transformational phase, and so we did reduce the size of the company at that time. And what happens with that is typically, and as I said earlier, we were very, very open about the kind of culture and what we were running, and frankly, it takes a personal set of risk taking to stay with a transformational voyage like we went through. And so it was a natural culling, and those that stayed we're all in, and just I can't say anything but the utmost praise for that spirit of AMD. And again, AMD's always had a culture of innovation. It's always had a
Yep.
spirit of being the underdog.
Yeah.
And
Jerry
that
Sanders brought that spirit. All right.
Jerry Sanders did, and so we married all of that spirit with a very rigorous execution management. As I said earlier,
Yeah.
very crisp development milestones and metrics that drive the right behavior. And so, that's the other. There's that whole culture of innovation. It's not just one type you need. I mean, to have innovation, you actually want that wild dreamer type, but you also want the pragmatist. You want the deep, narrow expert that's a super detailed in one field, and you want someone that's broad. You want, actually, it turns out it's bringing together a diversity. A diversity of talent, a diversity of cultural background, gender diversity. I mean, it's all of those things I absolutely think are essential for the right innovation dynamic.
Absolutely. There's a question that popped across about the board's role as well. So I guess my question about that was, was this sort of a core C-suite and a board in agreement type of decision, like we need to move, or was it almost the C-suite convincing the board, hey, this is where we need to go, or what? And how did the board help you, make those decisions and be able to execute and say, okay, these are the budgets and this is how we're going to invest in this
Sure.
turnaround, and let's go. What was the role of the board during all of this?
We have a great dynamic with our board. I'm very appreciative of their support. And it's set up as, I think, my own opinion, I think the right relationship between management and the board. I mean, management owns strategy, management owns the execution. Myself and Lisa were brought on, to with a specific task, as well as the other executives that then Lisa brought on as she became a CEO. So our march, our direction was clear, our strategy was clear, and the board has been very, very supportive. But just like I talked about the high communication that we run across AMD, and our across all of our colleagues, internal to the company, it actually takes that same communication with the board, and we're very fortunate to have that. So we are very transparent on our strategy and aligning there in the budgets, and they're transparent back, giving us guidance on that strategy, and it's worked extremely well.
And staying sort of in this culture, going back to that talent and hiring, and looking back at the last 5-6 years of this innovation effort, as well as now the last 6 months of managing employees this way, has it changed the way you hire? Are you looking for different types of qualities in people? Do you find yourself hiring different types of people, and are you looking and or finding these types of people in non-traditional sort of ecosystems, or because obviously now you're not really out networking, right? You're not meeting people at conferences or meeting people out in the ecosystem physically. So I'm just curious, is it your process to your approach to hiring, and the types of people that you're hiring now is a little bit different?
That's a great question. Look, hiring is fundamental. I mean, any technology company, you're only as good as the people you have. And the kind of talent you need changes. So in my role on R&D, when you go back, 7, 8, 9 years ago, I was really looking for disruptors that could think very, very differently, and didn't mind breaking molds, breaking some glass. We knew we had to break some glass. And so that was a key criteria for me. As we've gone through the turnaround, and now we're in, essentially, broken into, again, all the top cloud providers, all the Fortune 500. We don't want to lose that innovation, but again, that's running super strong. We have an incredible roadmap going forward. So I'm also trying to just strengthen our ability to scale. So that's folks that have really run in an expanding business, and and helping us ensure that we can expand at the rate we are. Our revenues are going up, our hiring is going up. And so you ask, how do you do that in COVID-19? It is harder. You find that you rely on your network you have to introduce you to others. It doesn't happen naturally like it used to. And so networking is more important than ever in this environment. And then you meet folks virtually, like the format we're on today. And again, we look very much for a culture match as well as the specifics go with the job. I think that's essential.
Agree 100%. And you did mention innovation at scale there, and that was also part of our sort of a promotional hook here in driving innovation at scale. You've shared some great insights into managing innovation successfully. Let's talk about the at scale part. This was clearly a global product rollout, and it had to happen fast, and it had to happen at scale, and continue, and has to continue at scale now, right? So you keep those revenues and Wall Street happy. Talk to us, your best practices around the at scale part, and driving innovation sort of at this global scale. What are your thoughts on that and your advice to people out there to drive it at scale?
Yeah, really two pieces. One, you have to architect for scale. When we plotted the turnaround, one of the things that we did, again, very, very early on, when we were plotting the new CPU cores and new GPU cores that would take into high performance, we architected a modular approach. Modularity has been so huge to so many industries. And most of us drive an auto every day. I mean, that auto is part of a modular process. How all the piece parts come together has been architected such that you can have any auto manufacturer has multiple lines of autos, yet they have shared components as well to make that car. And we architected that across our chip designs, as part of this turnaround. So we architected for scale, and we created a roadmap that would always have multiple generations in flight. So while one team's working on a given CPU or GPU engine, and they're in the ideation, the innovation phase, another team has already got the previous generation along the development track, and the generation before that is being pushed out into production. So innovation to scale, you really have to architect it, and then you have to implement in a way that's almost like a manufacturing line, where you're in a pipeline process, so that you never miss a beat. Our customers, they need that product refresh every cycle. We can't miss a beat here, and we won't. That's our commitment.
And a question just came in: how many years did you look out, sort of per generation? I imagine that's a generation of chipsets, I guess.
Yeah, from a brand new CPU or GPU, it's actually a 3 to 5 year development process. So just our turnaround alone, it took us 3 to 5 years to get those new high performance chips out. That's why they launched in 2017. And then, generally we run our roadmaps looking 3 to 4 years out. And then we at AMD, the way that we have set up is I have a research team that's looking beyond that. So they're looking at the cutting edge of trends. And again, this is where it's great that we are a little smaller and more nimbler than our competitors, because our research team isn't like an ivory tower that just sits off on the side. They are looking beyond that 3 to 5 years that the rest of the R&D is running on, but they work seamlessly and pass those ideas, transfer those ideas into the R&D team. So it works very well for us.
And do you leverage open innovation in any kind of way, Mark? Is that something, whether it's even just could be working with universities, but are you in, is there a broader sort of open innovation ecosystem that AMD taps into?
We very much value our relationships with universities. We have probably about 6 universities that we've really focused with and try and partner with. We also are members of just certain conferences. We participate in technical conferences, and by the way, that's gone virtual. So that didn't stop with COVID-19. So we're still sharing that we just had the Hot Chips conference last week, and we had several papers from AMD there. And so yeah, it is the academia relationships, it is the technical conferences, and frankly, what's great about the chip industry is it is brutally competitive,
Right.
but we actually also all partner and compete. So we line up on certain open standards, how one chip technology talks to another. We have a number of standards, so we partner there. You talked about APIs, application program
Yeah.
interfaces. So for our software stack that we've developed to optimize machine learning on our CPUs and GPUs, we work with the industry on application programming interfaces there. So yeah, that's what I love about our industry. You wake up every day and you've got to run as fast as you can. It's so competitive, but it's so collaborative in terms of what we're trying to do internally, and then frankly externally, so that we create a true ecosystem of computing.
That's great. We'd be remiss to not talk a little bit about the future before we leave here. We got about 5-6 minutes left. But the one question that I did want to get to, that you'd mentioned metrics around risk and all this innovation, this process, that time when you got to sort of, cut bait and say, this isn't working. And my question isn't so much trying to get into your head about understanding when that is, because you probably know when that is. My question is more around who should make that decision. What's the decision-making process, the best practices around the decision-making process around, okay, we need to, this isn't working and we need to move on to something else, as it relates
Yeah.
to innovation, and it's not, okay, this isn't working, it's not achieving what we want. How should that decision be made, and who should make it?
Well, it's funny you mentioned that. You almost say, well, it should be obvious. It actually is not obvious at all. It's one of the most difficult parts of the innovation process of when, these are all, every idea that you have, I have, anyone listening to us has an idea. That idea is your baby. I mean, you get
Right.
emotionally attached to that idea,
Yes.
and saying, you know what, that idea is not going to fly. Let's kill it, move on to the next one. Turns out it's really difficult. So the approach that I've tried to drive at AMD is you really got to agree up front on your criteria. What's the success look like
Yep.
of this idea, this new product, this approach that we're on? What's success? And then you have to have the metrics along the way. We had one of our CPUs was going, and we were all very proud of it, but the metrics said it wasn't going to make it to market in time. But the data showed us that early enough that we were able to react, adjust the idea, the approach that we were taking, and we nailed it. Hit our time to market, and even exceeded the high performance goals that we had. So it's hard. It's really hard to do to call it when you have an issue. And my recommendation I give people is. Earlier, I said that we have a culture of communication over communication. Well, when it comes to when you're not hitting metrics, I urge people overreact. Call a crisis maybe just before it actually is that crisis. You can't overreact on those things. And by the way, if you called it too early and you dig down deeper and you're okay, fine, keep going.
Right.
But you really got to be always ready to react if the data is telling you that the idea and the innovation is not on track. You've got to be ready to move. And that's a role of leadership. That's the technology leadership. That's management. And if you have a culture that is being transparent and sharing that and putting it at the table, then you make the call.
Right. And I imagine also being transparent and just being right up front with the person whose baby it might be. Right. It's like, and bring them in and say, hey, look, we've tried this. It just hasn't worked. Let's maybe try something else. And instead of maybe making that decision remotely and sending them a tweet or something.
Exactly.
I'll stay away from that. So let's just talk a little bit about the future while I have you for a couple more minutes. There was a question came in, which is a bit of a geek out question, which I'm fine with, even though I did not know what CMOS was until I looked it up on the internet while we were chatting. But talk to us about the future of computing. And the question I saw come in was sort of, does it require a post-CMOS type of what looks like, I would assume, is a digital circuitry sort of design structure? But maybe, if you want to weave that into your answer of, what excites you about the future of computing? Because I interview people from media and entertainment. I interview people from hardware. I interview people from consumer product goods. And it's always interesting asking people what the future looks like. But when it comes to computing and devices and all that, the chips are incredibly important. So you guys have to have a pretty clear view on where things are going if your product cycles for the guts are 3 to 5 years out, right? So
Yes.
what's exciting you about the future of computing, and where are we in 2030 in regards to chip design and things like that?
Well, we are still in the acronym used there. It's called, I'll geek out and tell you the acronym. It's a complementary metal oxide semiconductor,
All
CMOS.
right, there we
So
go.
that is how almost any chip you're operating, it's in your phone, it's in your thermostat in the wall. I mean, CMOS is the predominant technology that we have today. But we're getting down to where the thickness of the very transistor that we make, the separation of making a transistor is actually getting to be only several molecules thick. So you're getting down
Molecules.
to, yeah, molecules. You're getting
Wow.
down to physics. And there is, because I've been in the industry over 35 years, I predate CMOS, and I was there for other semiconductor approach. And every time we hit the end of the road on those other ones, there was the doom and gloom, and it's the end of the semiconductor area, and then there was an innovation. And there's very good innovations in store for semiconductors. So there will be new structures, things like carbon nanotubes and changing the way that the transistor is made and going vertically and stacking, and also what we innovated at AMD is chiplets. So rather than having to grow the size of the chip constantly, we use that modularity I talked about earlier and broke these designs into smaller chiplets. You may not see it because it's under the covers, but when you buy these leading edge Ryzen PCs today, whether it be a desktop, where you go into the cloud and you're operating on an AMD based server, what we actually have is small chiplets connected both horizontally and 3D stacking. For instance, we stack our memory chips on our graphics processors. So we both these new materials for the semiconductor itself, and then new packaging and stacking techniques are very, very promising going forward. So it's different. It's not the old Moore's law. It's a new and exciting way in which we'll be piecing together the functionality using CPUs, GPUs, other acceleration chips that speed the workloads that we all need to get our work done.
And what excites you on the product side? The next generation of these great AMD chips, they're going to be inside, what types of products that excite you? Does it get into the sort of Internet of Things and everything's connected and maybe nanotechnology? But what excites you about kind of what these chips are going to power in the future?
It's what myself and all my colleagues really appreciate at AMD. We get to impact people's lives. And if I just look at the next 2 years, we're launching new high performance PCs and servers. We have our third generation of what we call Epic Server coming out this year. We have our fourth generation of our Ryzen coming out. We work with that same CPU and GPU. We have customized that for Sony and for Microsoft. Each of them have their next generation of game console coming out later this year, and it has the advanced graphics ray tracing, where when you watch an image and the light rays are bouncing around, the math is going on under the covers in the graphics processor that it exactly matches the way that light rays bounce around. So it looks incredibly realistic. And then looking at next year, we have what will be the world's most powerful supercomputer, a 1.5 exaflop, which is 1 billion times 1 billion operations per second, coming out with Department of Energy, Oak Ridge National Lab next year, and then that is used for the world's most difficult problems. So we feel incredibly fortunate to do what we love to do, and that's push technology, but push it in such a way that it's useful. It's helping people solve problems. That's very rewarding for us.
That's great. Look, I mean, I didn't get to 6 or 7 questions from the audience. I have 7 questions written here that I didn't get to, but I want to thank you. And on our way out, just my question: what do you read to stay informed or motivated or inspired? I think I found a quote from you in Tom's Hardware, which is maybe a little bit geek out, but whether it's on the geek out side or whether it's just kind of on the, the future of computing, what do you read? And it could be a known publication that everybody knows, or it could be a more obscure publication or blog or newsletter, for you to stay informed.
Well, it's all the above. I mean, I do love technology. So when I open up every morning, the Wall Street Journal or the New York Times or whatever, I go first to the
Right.
technology section and what's news there. I'm a member. I'm an electrical engineer, and I'm a member of the IEEE. It's our standard that it has great technical publications that I stay abreast of, and periodicals they put out. And I really like then I have several blogs and technical press that are in my field that I check, and I do this actually routinely every week, because you never want to get so full of yourself or your company that you're with that you think you've got it all figured out. Never, ever, ever. So you have to constantly be reading what's out there and gleaning how other people are thinking about the industry and where it's going.
Well, a former competitor, one of his most famous lines, Andy Grove, was "Only the paranoid survive." So, I mean, I completely agree. Look, Mark, like I said, we could talk another hour. I know you're super busy, and I really appreciate you taking the time. I hope my audience found it valuable. I know they did. I learned a lot just on the call, and even in our brief discussion. So, so thank you again. Really appreciate it, and I hope to talk to you again in the future.
Drew, thanks very much for having me. I really appreciate it.
Thank you, Mark.